A gas is compressed isothermally to half its initial volume. The same gas is compressed separately through an adiabatic process until its volume is again reduced to half. Then, okay, we'll see this one, understand this one with the help of the PV diagram. This is the PV diagram. If I draw the curve, this one, this is the curve of isothermal curve. Here T is equal to constant. And this is the curve for adiabatic curve where PV to the power of gamma is equal to constant. Okay. Then if I draw a straight line here, and is this part is the expansion part, expansion process, and this region is the compression region. This is the region was compression region. In the compression region, if I'm going to draw one more line here, and how we can calculate the work done? The area under the curve is what called as the work done, right? Then assume this is the work done from the isothermal, and this is the extra work done, it is for the adiabatic. Okay. Then by observing these curves, we can say that from the option, compressing the gas isothermal will require more work done. No. Compressing the gas through adiabatic process will require more work to be done. Yes. Option B is the right answer. You can see the sum statement also here. The external work done is equal to the negative of the area enclosed by the curve on the volume axis. Additional, the work done in an adiabatic process is greater than the work done in an isothermal process. So, compressing the gas through the adiabatic process will require more work to be done.